Hello, am I audible? Ronan,
Yes,
can you
yeah.
please confirm, am I audible?
Yeah, I can hear you, yeah.
Okay, okay. So the material for the lecture has been uploaded on Loop. Just download the material, the data file, and there will be a RMD file, which is basically to do a hands-on and practical exercise for the time series. Okay.
Yeah, thanks.
Can you see that?
I always see this, but I think that this.
Just 1 second, it will be uploaded. Follow the steps here. And you can write R installation. Okay. Yes, so download. Sandeep sir, I have shared one Excel file for our installation. Upload on the Loop system, okay, on this financial time series. Yes, yes. Okay. So just download this R 4.3.3 for Windows. Yes, that's the recent version. And then once you go for installation, what you have to do, C drive, you create a folder, name it R, and during installation, show the path for the installation to be here. Okay, I'll just do it for you. So see, let's say I have downloaded 4.3. Once you have downloaded it, you have to click. Okay, so this is my R file. See, it will pop up like this. Yeah. You say yes. And then it will ask you the path. Okay, English, okay. Next. See, you have a path here. This is by default installation. Don't go for it. Else you'll have to set environment path and it will be tedious. So what you have to do, browse. Okay. And then give the path in C drive. Okay, in C drive, I have created a folder with the name R. C. Yeah. Okay. So once you click OK, the path here will be C, R, and the R version. Fine. And then when you press next, take the default installation. Most of you will be having a 64-bit system. Okay. So just go next, accept defaults, next, everything next, you have to just click. Okay. So if you want a desktop icon, it's fine. But if you don't want, it's also fine, because we are not going to directly work on R. We'll be using an IDE. Okay, IDE is an integrated development platform, which makes things easier, because our platform is very crude. It's not very handy. You don't have that GUI interface. But our studio runs on top of R, then it has a GUI interface. But RStudio requires the system to have R. Okay, same way if you are using Python. So, okay, done.
Guys, put it into the.
Yeah, okay, okay. Hold on now. Go scroll down.
Same way if you have used Python, let's say because most of the people they use Anaconda environment to install. So automatically it installs the Python. At the same time, you have an IDE. Let's say you are using Jupyter Notebook or Jupyter Lab, so or Spider. So let's say if he has used Python, you must be using some IDE like Spider or Jupyter Lab. Same way in R, also we use an IDE called RStudio. So once you have installed R, search on Google RStudio installation. RStudio installation. Okay, so this page will pop up RStudio desktop. Okay, you just have to download RStudio for Windows, take the default installation. Yes, RStudio desktop for Windows. If you are using a Mac, then RStudio for Mac. Okay. No. That's why I told you to install on C and R. Will I put the studio in the No, take default installation. The people who have worked with Python, they know this path stuff. It's very irritating. So here, for the time being, we are not going to use any dependency on clusters or other language where you require path. Yeah. Okay. So there is a dependency package called R2, which actually integrates R with C++. So many of the algorithms they require C++ for execution because it's fast. So R and Python they provide an interface to interact with that C++ compiler. For the time being, for this course, you don't require. Maybe in future if you require. So the Excel file shared on loop named R installation has that R tools installation stated how to install R tools and how to set the path. Okay. So, but for the time being, you stay with me. Arts installation for RStudio, take the default installation. Perfect. Done. Yes, exactly. Once you have installed RStudio, okay, then open the file that has been shared on loop. You will find a file with an extension RMD. Okay, can you see on the screen? There will be a file with an extension RMD. There my cursor is. Open that file. Yes. So I would advise you to create a folder and put this file as well an Excel file. So there will be an Excel file named equity.
So I'm seeing R code data installation under financial.
And then you have some other file? No? Actually,
Let me refresh.
I don't have that access. So that's why it becomes troublesome. So just one second.
No worries. Thank you. It's still installed. RStudio is still installed.
It's fine. I'll just get that stuff. It will take some time, but it's okay. No need to bother. Will be.
Oh,
Every-
yes, sorry, it's up on the loop page as data, but the file name.
Yes, the file name is equity.
Okay.
Yes. Is it there?
You know,
So download.
installation.
Yes. So download the R code as well as the equity dataset. Keep it in a same folder so that you don't have any issue related to setting the working directory and all.
File itself stays as save link as when you click it, it's just it doesn't download, it just opens. Oh, sorry, download maybe.
Download both the files.
Yeah,
The R file as well as the equity.
yeah, so our
Then you download the Excel.
yeah, download the Excel file, no problem, that auto downloads, but
Right. Okay, just open the R code. Copy everything from here.
studio or,
The working folder where you have the equity.
oh, I'm gonna create that now, so
So this.
yeah.
And then that's what's called. Save it here.
Yeah, file there too,
Yes, now open the folder
yeah.
and open the file. On loop, I have that access, FPS access. Designation, you have that like R studio activity.
Okay, do I go into,
So you, no, sorry, so you downloaded these three,
I want, I can't seem to get, every time I try, it says,
You have to right click it and save link as.
oh.
Okay.
you should be able to download data. That's just the-
You can have, you'll be able to download it.
This.
Yes.
Click it, click download.
For the R file, right click save link as.
Then it's going to do that as a default.
Yeah, that's fine, that's okay, you can go there. Right click the R code.
Oh, no, I've actually already gotten it.
Oh, you got it. Yeah, so just put that both all into the,
Oh, actually, yeah.
user machine default 64 on, yeah.
Yeah, use the machine.
So, when I right click that,
Uh, Sorry, go back. You may have to crunch reports.
put the OR studio into, because it's just been downloaded. I would just open it up.
No, when you click the data code file, it will prompt you to use RStudio to open.
Yes. So once you click this fts.rmd or whatever name you have given, it will say to use the machine default 64-bit to open up. Are you able to open up? You will find somewhat like this.
So I just go in here.
Yes, just click that file. No, this is our installation. So they have been downloading.
It's not here. Sorry, already. Okay, so
So have you installed?
just
RStudio.
I
Yeah, you do.
I did download it.
Go to your downloads. Take the default installation. Okay, next.
Next.
It's okay, like we'll be on the same page. Yes. So for the time being, just see, have a basic workaround with this platform. Okay, many of you who have used Python or MATLAB, so if you have used Spider, it's somewhat like this. So can you see there are 4 quadrants here? This is one section. This is another section. Then you have this section and this section. Okay, 4 panes are there. You can say 4 window panes are there on this ID. So on the left side, this one, this is the place where we'll be writing a fresh code. Okay, this is, just imagine, let's say if you are working and this is your notebook, maybe you want to do some exercise as a rough work. So think of this console, this place where my cursor is blinking, as a place to do your rough stuffs. Okay, we say in programming dirty code checking and all. Fine. This section, then this pane, this shall I repeat this?
Yes.
So see, 4 panes are there. When you will open that file fts.rmd, you will have these 4 panes coming up, popping up. Okay, so this is the place, follow my cursor, this is the place where we will be writing codes or taking any notes. I'll come to this, the power of using this as a notebook. This place where my cursor is blinking, this is the console. You can think of it as a rough place in your notebook. So let's say you are doing something, you want to perform some rough calculation, rough program execution, you can do it here. Okay, this is the place where anything that will be loaded in the R ecosystem will pop up. So once we'll execute, you'll see data populated here. Okay, and this is the place where you will have the help from the R. Let's say if you want some help from the R, the things will show up here. Bottom right pane. Fine. Is it fine? So have you installed RStudio? Are you able to open this file, Financial Time Series? Now see this section, the first section, make this a habit that you, every time if you code in R, what you have to do, you have to use a file. So there are different types of file in R. One is the basic .r file, and this is a notebook file. So can you see on the ribbon, I have clicked file. You have an option of R script. Okay. And you have an option of R notebook. Always choose R notebook. I'll say the reason why. Okay. Why? See, R notebook will have an extension .rmd. The reason for choosing R notebook is it's like you have a register or a notebook where you are free to write anything as a comment as well as you can code. Got it? So a single window where you can take notes, you can create table of contents as well as you can code. So else what you'll do, let's say if you are not using a notebook format, you'll code somewhere and you'll prepare a write-up somewhere else. So you will have to toggle back and forth. Here, can you see here? See, whenever you encounter this kind of chunk, we call it chunk, R recognizes that whatever has been written inside this is a code, and whatever is written outside this is simple word. Is it clear? So, and make sure that you have this visual clicked up. Can you see the visual? Just follow my cursor. It will look more fancy, and then click the outline here. So you'll find table of contents here. Can you see? So let's say if I want to, if you have made a long code and you have to reach out somewhere, you can directly click and you'll reach there. Okay. So once you will, and so see the way to create these headings, how to create these headings or subheadings. Can you see here header written? If you click here, whatever, so this header one is the biggest heading. Header 2 is going to be a subheading. Header 3 going to be subheading. So can you see here financial time series is the major heading, table of contents. Then you have subheading. Then you have subheading. Then under data import, I have one more subheading, plot.
Library data input are both heading 2.
Yes. So these R will recognize these as simple words. Okay. Or you can say table of contents. Whatever has been written inside this, can you see here written R? Whatever has been written inside this will be considered by R as a code. Okay. Whatever written outside this code chunk is simple word. To insert a code chunk, what you have to do, see, can you see here?
Yeah.
Follow my cursor. If you click here, you have an option to click what programming language you want to work. So single ID, let's say if you want to integrate Python also, you have Python script also. If you click Python, whatever you'll write inside, this R Studio is going to treat it as a Python code. Okay, so it's like latex on steroids. Okay, informally. It's a powerful interface. All those data science languages, they are going to integrate because they are facing threat from some new upcoming languages like Golang or Rust. Okay. So R, Python, they are creating a single interface where you can do, because in some ways Python has powerful libraries and in some ways R has powerful libraries. So the people who are working in the field of data science, or let's say in the field of quant finance or computational finance, they actually harness the power of both the languages. They need Python as well as R in their portfolio. Okay. Some of the advanced statistical libraries are available in R, which are not there in Python. And some of the machine learning, deep learning libraries are there in Python, which are not in R. So if you are using a single interface, you can use the output of one language as an input for the other language. You don't need to work on two separate platforms. A single platform, you can work here. Is it clear? So, but here today the session will be in R. So let's say you want to insert a code chunk, you just have to select. So let's say I want to insert a code chunk here. If I go here and I click R, see what will happen, a chunk will appear. Are you able to create a chunk? So now whatever, don't remove this, okay, let it be here, this R. And then whatever you are going to write inside this, R will treat it as a code chunk. Fine? Any doubts, any questions? Let me know if I am going too fast or too slow. Okay.
Essentially focusing on create a chunk of. So I think we put it in this chunk. So
How do you include a chunk?
no, like how do we, so that chunk, so I see it in chunk there, so there's like a gray box.
Yes.
Everything outside that box.
Is a word.
Will be.
Let's say you are attending this lecture. I'm saying something you want to take notes. So let's say I'm saying that time series is very important. Most of, so you can just write it here as a note outside this code chunk for your own notes, for your own note keeping. Okay. It's like you can create a book for you where you have the notes written as well as the codes written. A single place to do everything. Is it clear? So whatever you are going to write outside this code chunk, R is going to treat it as a word. Okay. So think this R code has been embedded inside a word file. And then let's say best thing will be once you, let's say you have to pass on this whole stuff of time series, you can actually knit it. So can you see here knit? Okay. On the top, follow my cursor. You can, whatever you have done, code write up, you can knit to an HTML, you can knit to a PDF, you can knit to a Word, and you can give or share to your colleagues or anyone. Okay. Isn't it cool? And then you have the option to actually hide the code and only display the results. Okay, let's say you don't want to share your strength, that is coding and everything what you have done. You just want to share the final output. Let's say you are working on a project where you have to create a report which includes some write-up as well, some kind of data analysis. So you can have the write-up done, okay, and the data analysis output into a PDF or a Word file, and you can share with your colleague or supervisor. Okay. So it will take some time to be comfortable, but once you reach that, like once you are comfortable, you will find this tool very handy. You can use this single interface not only to create, not only to do analysis and save it in a PDF, but you can also have PowerPoint presentations, everything. So it has got lot many stuffs, but today we'll have focused more on the time series aspect, but you can explore on your side.
Could we use this for, Python?
Yes. See, let's say I have some data where I require a library which is present in Python. So I need to insert a chunk, code chunk, which this environment should recognize as a Python chunk. So I'll go here. See, can you see Python? You click Python. Okay. So why it's important? Let's say the output of this Python has to be used as an input for some R library. It's like, let's say after running the code, I have an output generated. Okay. Let's say I don't have this interface. So what I'll do, I'll export that output onto an Excel file. Then I'll import that Excel file in my R ecosystem and then I'll use it. But here what I'll do, I'll catch that output in a variable and I can use that variable in my R code. Is it clear? So
It's fine there.
let's say you have run a machine learning algorithm, you have the output, and you want to use that output as an input for some advanced modeling in R, where the library is more developed enough. So both these languages, they have their strength. I want to use the best of these two languages. So I'll take the output of Python and I use that output as an input in R. Let's say output of R can be used as an input for Python. And you have much more. So let's say if you are doing some kind of Bayesian statistic, so you need these things, stan. Okay, let's say you want to integrate database into it, so you can use SQL. Can you see? Okay. Let's say, so all these things are there. Still, this platform is under development. Maybe in future you will find much more programming language because they are going for an integration. So each programming languages, if they are better in something rather than expanding in every horizon, it's better to focus on something I am good at. And then we'll have a platform where we can integrate. So in real world, maybe you are doing some data analysis on the back end, but that is being hosted on the website. So on the front end, let's say Java is there, okay, or PHP is there, but on the back side, you are using Python or R. Clear?
Yes.
So this is how, let's say you as a professional, if you are, if you have developed yourself and you are working in these kind of smart platforms, so you working on a particular module, it will be very easier for your supervisor or other team members to integrate with you, isn't it? So this is how this integrated system setup in a, let's say in an MNC functions. Okay, some people are working on the data analysis side, some people are hosting that on a website. Okay, some people are handling the database, data engineering, data harvesting. So it works in, you can say, in a network. Okay, and so more easy the network integration, better will be your productivity, better will be information flow. Okay, is it clear? So let's proceed on to the time series aspect. So anyone of you like previously worked with financial time series, have any idea, would like to share? Like, so, and I hope that all of you are expecting to work in the financial domain in future. Okay. Let's say if you plan to, so one way is that one side is you are working as an investment banker, more on the side of lending out money. So in that case, you are focused more on the corporate finance side. But let's say you are working as a portfolio manager, as a hedge fund manager, where you will be actually handling the market data. Market data means, let's say you have a stock exchange. Okay. I'm pretty new to Ireland, so I do not know the stock exchange market here. But I can give you example from US. Maybe so. Let's say you have uh, Nasdaq or NYSE, and so many securities are trading there. Okay. As a portfolio manager, you have the responsibility to actually use that data as a source of information to achieve some objective. Okay. So I would like you to think, let's say if you are a portfolio manager and you have these data available, what do you think would be your objective? What could be your objective to use this data for? Absolutely. Why do you need to forecast? What's the why there is a need to forecast?
Yeah. So the market,
Yes.
and then
And that, yes. All right. So you are trying to predict the market. Okay. And based on your prediction accuracy, maybe you are going to take a stand that these are the securities I am going to advise my clients. Okay. So most important aspect will be the prediction accuracy. Financial time series data are very complex, but what's important theoretically, or you can say conceptually, that let's say today you are observing a price for S&P 500. S&P 500 is the index, broad index. Okay. So let's say you are observing an index closing price for today. So many factors, macroeconomic factors, behavioral sentiments of investors, they have shaped that price. Okay. If you try to go and find out on a micro level that what's the influence of an individual investor, what's the influence of the inflation in this country, what's the influence of policy rates, it's going to be very complex exercise because so many complex macroeconomic fundamentals have cumulatively shaped that price, which has been observed by you. But what, as an analyst, what you should understand that this data that I am observing is not only the data, it's the information. Information about what this actually shows the real, based on the people's sentiment, based on the macroeconomic factors that have shaped. This is the price that S&P is showing. Okay, based on this concept, or you can say based on this assumption, we think that this price series or this data series has information in itself to help an analyst predict the future. Okay, looks, sounds fascinating. Sometimes you can question it. Of course, it's questionable because I am assuming that whatever price I am observing, it has been shaped, okay, based on the previous data, the previous observation. Let's say yesterday S&P 500 is 500. So I assume that this 500 is being used by many analysts as an indicator that tomorrow this is going to rise or fall. Okay. So, well, this is not the case always. You need, apart from some quantitative stuff, some kind of fundamental analysis. Okay. To actually complement your final analysis. But yes, these models actually give you an indication. Okay. Your final decision should not solely rest on the prediction. You should also do your fundamental analysis, but yet these financial time series statistically bear some connection. So they have the potential information to forecast future to some extent, not exactly, but to some extent. Based on that, we have some time series models, okay, which we will cover today. Fine. So one important thing, you have some question? No, okay. So one important thing that you need to understand, we are going to, whenever you hear that I am going to handle something from a statistic perspective, okay, so the first thing that should ring in your mind is that I am going to work in a probabilistic framework. Okay, the first thing that you should think of yourself. So whenever you are going to work in a probabilistic framework, there would be certain set of assumptions for any statistical model that we use today. Okay, so your forecast accuracy or whatever you intend to do depends heavily on the assumptions that has been met by the model. If the assumptions are not met, then there, of course, there is no chance that this prediction stands, like it's going to help you out. So make sure if you are working in any statistical or probabilistic framework, the assumptions that are associated with that statistical model has to be met. Else, that statistical exercise makes no sense. Okay, so let's say if you people have done any previous lecture on OLS, ordinary least square. Yes, so OLS also is based on one very known theorem called Gauss-Markov theorem. Have you? So it's also a set of assumptions. Okay, if those assumptions are not meeting, then in that case, that OLS estimation, coefficient estimation is not right. Okay, maybe your model is misspecified. Okay, it needs some correction, some transformation. So in the same way, time series models also, they require some assumptions which has to be met. We'll explore this one by one, but first install the libraries on which our model is going to be dependent. So this first code of chunk is the important libraries that we are going to use. To run this whole chunk, what you have to do, can you see on the right? If you click all, it will run the whole chunk. So what I'm trying to do, I am first storing all, so these are all packages, tidyverse, time tk, all these are packages. I have clubbed these packages and stored in a single, you can say, bundle. And I have named that bundle as list of packages, which in a programming language, we call it as a variable. But let's say if you don't know, you can draw an analogy that it's a big bundle, which is storing all those packages. Okay. So you just click here. So in case what it is doing, I am storing all those packages in a single bundle. And then I am checking whether this bundle of packages is installed in your R ecosystem. If it's not installed, it's going to install. Okay, yes, it will install. So just click this code chunk, all these packages will install.
And also further down, you have
Yes. It depends because last class it was we tried to cover everything, but it depends upon the reception. Yeah. That's why yeah. I don't know whether we'll be able to cover it. But this will be the new. Let's say you want to use it in future exam. So all those write-ups, everything is there. Explanation. Once installed, just let me know. Till this point, is it clear? Like, I'm like the flow is fine. I don't think it's very fast. Pace is fine. Just intervening fine going. And if you're not getting something on a different perspective, just let me.
I guess I'll play what other file types can you load into this? And kind of use we got a Python and it's essentially you Python codes, Excel, CSVs, and everything else. But yeah.
So we'll be actually importing an Excel file also. I'll show you.
So you can apply different types. You can apply kind of R.
Yes, we'll be importing an Excel file using R. So R also has a way to import Excel file. You can also import directly an SQL file. Let's say this, you are working in a company and you have to work in a database, okay, which has a long list of data. So you need not to have that data in your own laptop. Okay. A server will be database server will be there. You will connect this R Studio with the database server. See, there is connections written there.
Oh, right.
So connections, actually you will establish a database connection there and you can import the data from that database. Let's say your company Oracle, you can use Oracle, it's using MySQL. You need not to have that data on your laptop. You can just import that data to this connection, work on that data, have the analysis done. So maybe you are working on terabytes of data. You cannot store on your laptop. We'll be here working on an Excel file. But again, yes. Then again, you have APIs. Let's say you are working, your company has a subscription for Bloomberg or Replicate. So you have APIs to directly fetch the data from Bloomberg or Replicate. Then there are some open sources. Let's say Yahoo.com, Yahoo.com is there, Google is there, Fred is there, Quandal is there. They have limited data for financial and economic data, for which libraries are there in R. Using those libraries, you can directly fetch that data.
will be doing that today. But yes, those data are not updated. It's just for learning. I would advise you that if you are working on a financial sector, either go with Bloomberg or Refinitiv. But it depends because they come at a heavy price. So it depends like your firm which is paying for Bloomberg. But for sure, they will have some data prepared there, for sure. Either Bloomberg or Refinitiv.
If you don't have access to their work, I mean, is there?
So then your analysis will be a bit late than rest of the analysts. Let's say Bloomberg analysts, they have the most recent data. So they will have what they do. So they have their reports published. Those reports are actually paid reports. More accurate, more new your report is there, more people are going to buy. This is the reason why Bloomberg is building so much money because they have the most recent data. How they manage to do it? They have their servers installed. Yes, of course, money is doing so. They have servers installed in your security exchanges. Okay, so they have most recent data. They work on high frequency data. So you can also use these platforms to work on high frequency data, tick by tick data. More the periodicity of the data, more information you can leverage for your own game. Okay. Less the periodicity, let's say you are working on a financial data and you have downloaded monthly data. So between a month, so many things change. Okay. Daily data, you will have more information. Every day, day to day, how it's changing. Tick by tick data, which is high frequency data, like people who are doing trading, they use statistical arbitrage and all. So they need this high frequency data. Okay. Because then they can leverage that. Let's say I know some of the commodities, they are traded worldwide. So all of a sudden, if I see that crude is being traded in the Western world at some price and it's at a lower price, let's say in Asian market, but it happens in just microseconds. Okay. This price discovery and this leverage is available for a trader for like microseconds. So your code should be very fast. So technically speaking, those people use languages which are fast. So R and Python, they are not that fast. They use most of the people who are working on trading desk, they use C++ or C because these languages are quite fast. But let's say you are having a task of, let's say you are a portfolio manager, you are handling investment where the investment horizon is long. So in that case, you, let's say for 5 years of horizon, so then you can rely on the daily data. Okay. And then you can use that data analysis from that data to choose a security universe. Security universe means you will have bunch of children. Some from equity, some bond, and some commodity, and then you can allocate it. Okay. So packages have been installed, but it's still going on. Once you have run this code, if you can see no error popping up, don't bother about the warnings. If there is an error, just let me know. Done? Yes, so just focus here on the console. See, because you will have lot many information here. Focus on the console. If there is no error popping up here, then it's fine. So what it is showing? Oh. Right. here, if you follow this code,
Yeah.
from here,
These are actually, you can draw an analogy in this way that R by default doesn't come loaded with all the packages that are there in our ecosystem. Our ecosystem CRAN repository is very huge. Okay. So people from astrophysics, they are also using some packages. People from finance, they are also using. So based on your utility, you are actually installing a package. So it's like, let's say I have purchased a car. So you have different variants in car. So here we have the base variant. Let's say base variant doesn't have a woofer system. So then before this, I am installing the woofer. Once you have installed the woofer, then let's say if I want to hear music, I will have to switch on the woofer. So these codes are actually switching on the woofer. In programming languages, we say that we are importing the packages. Okay. Before this is related to installation of packages. Installation has to be done once. So again, when you open your this same file, installation is not going to happen again, because already now your R ecosystem on your laptop has these packages installed. Okay, you just need to switch on the packages or import the packages, which is this one. Got it? So it's like once, because it R needs you don't need to have all the packages imported. It's like if I want to hear the sound, then only I will switch on the woofer, else I won't switch it on. Same way, I won't load all the packages until unless I use it. So let's say you are working on a separate file, you don't need these packages. So you need not to import these packages. Got it? So once we have done this, let's go to data import section. So see here, let's say I'll show you two ways to import the data. One through using a web API where we'll be fetching the data from yahoo.com. And second one we'll be importing a data from an Excel file, which is on your system. Okay. Whichever you want to. Yes. So let's see. So there is one package in R called quant mode. The package name is quant mode. If you want to see what's there in quant mode, there are multiple ways. One way will be you can just go to internet. Okay. Go to internet, just write, see quant mode. Once you write this quant mode package, you will have this something written like comprehensive R network. This comprehensive R archive network is actually a library. R library. Okay. It has multiple branches. Okay. So let's say one branch is related to empirical finance. So if you click it here, see, this is the quant mode library. It's a very big library. You can see what's there in this library. This is the reference manual. Can you see here? If you click it, you will have so many things. Detailed description of this library. What's there in this library? Okay. It has got, this is one of the famous libraries used by people working in the field of finance. So quant mode is one such library. Performance analytics is one such library. They are like heavily used by instructors also. So if you are taking any course from edX and all, they use these libraries. Okay. So then let's go back to this R. Same way, try to draw an analogy if you have worked in Excel. Excel, if you want to do something, you have functions there. Okay. You write function, automatically the arguments are shown. Isn't it? Let's say you do VLOOKUP. If you write equal to VLOOKUP, you will find arguments required. And you have to pass on the arguments in the same way Excel requires. It's not like that this is a maths or something. The person who has developed this R ecosystem, or let's say Excel, they have made it to work in that way that you have to pass arguments this way. So same way, R is a functional programming language where if you want to do something, you have to call some functions. And those functions, they have a specific way of passing on the arguments. So this get symbol is one such function which is actually used to fetch financial data. Let's say I want to know what are the arguments required for get symbols in detail, so I can actually bother R for help. How to ask R for help? You just have to write, see, this is my rough notebook, isn't it? I'll not be doing anything here. I'll use my rough notebook to actually explore detailed description of this function get symbol. See, this is a function in R. Okay. So what I'll do, I'll ask R for help. I'll write question. I'll write get symbol. If you'll write automatically, some of the functions will pop up. I want get symbols. You go there, press tab. You need not to write everything automatically. So it's an autocomplete option inbuilt in RStudio. You don't have to write the whole function. I just write get symbol, so it automatically shows up. I press tab, press enter. Now see here on the right side, you will have some documents popped up. Can you see here? Can you see here? See my cursor? I have asked R for help. So you should also know how to ask R for help. You just have to put question mark and the name of the function. So see, this is the detailed description. You can see the arguments. The first argument is symbols. Symbols in finance here means the ticker symbols. Okay. The ticker symbols, have you heard tickers? So let's say Apple has a ticker symbol. So you have to pass on the ticker symbols for which you want to fetch the data. Okay. Then it has multiple sources of download. So Google is also there. Let's say if you want to download from Yahoo, you write source Yahoo. Okay. And rest of the things, two important thing will be, if you want to fetch a data, you have to say that from what time to what time I want the data. Okay. So important thing will be symbol. Symbol means the tickers that you want. Source of the data, Yahoo, and my start date and end date. This is what I have to pass on. Okay. One way is that I can write it directly here, but I would advise you never to hard code. Try to link. Try to think it in a way that in Excel you use referencing. So let's say if you have a big model which is relying on certain inputs, you don't write the inputs directly in the model. You write it somewhere and then you refer it, you link it. Same way, these variables, so symbols I have to pass. I have created a variable called symbol and I have passed on these three symbols. SPY, F is for Ford, APL is for Apple. Okay, so this variable, if you just execute this line, so before that you have executed the whole code chunk, don't execute the whole code chunk. Let's say if you want to execute line by line, so see the cursor where it's blinking, you just press Control and Enter together. Control Enter. For Mac, it's Command Enter. Okay, so see in your console something has been executed. Okay, are you getting it? So you can check. Let's say if I write symbols here, values are here stored. So symbol is actually going to help me as a reference point. If I call symbols, automatically these three tickers are going to be called. Is it clear? So let's say if you are working on some, let's say if I want to fetch more data, I'll just include it here. So automatically my symbol will be updated. Okay. Then start date is there. Exactly. I am not trying to at this time, it's not going to throw any error because this symbol is only a reference. When you'll be running this get symbols, then it's going to see whether the ticker you have supplied exists or not. Then it will throw an error. Got it? So here I am just passing on symbols Symbol is just a variable acting as a reference. So then I have to also pass on the start date and the end date. I have passed the start date, end date to execute this line by line. Control enter. Execute with me. Control enter. Control enter. So you will see here these two lines executed. Everyone got this? You are done with the
Okay, so see how simple it is, and then do the same for start date. As well. Yeah, so now you have your symbols, the symbol.
The values are coming through.
It's like symbol. Variables that you can say, and then start date and date are like variables that you can say. So they, we're gonna try and go to, we're gonna do something, not go to whole date. Symbol. Data fund, CSV. I can get into a Python format.
Then one more library which gives you drag and drop feature for SPC. It runs on top of. Okay. It's very interesting library. Just have to, because visualization actually is important but takes a lot of time. Yeah, exactly. Yeah. So I mean ggplot you have to write down. Yeah. SPC actually does on the background. You just have to drag and drop. Yeah. Because before you Sonora, I was doing principal component analysis, this. The actual statistical analysis wasn't that long. The thing that took the longest. You just have to go on PCA. It's a small PR count. But also yes, PR count is there. Yeah, PR count is there. You just have to pass two arguments and it's done. Yeah, yeah. And then you have output, which you can use to fetch different. So output also comes as a form of list. How many outputs will be there? There you will have the eigenvalue. Yes, there you will have the residual. Everything will be there. Packed in, you can say stacked up, get as a list. Yeah, fetch each and every one. I'll show it here for ARIMA. But previously, you spent 10% of the time doing the principal component, 90% of the time negative graph, negative more. So the SPC I'll show you. Yeah, it's very handy. Yeah, that's good. Thank you. So done. So now run this code prices. See if you are able to run this. If you are able to run, then it's fine. Else you can use this, the second data set. It's fine. If you run prices, you will find on the right side this thing popping up. Control enter. Line by line execution, control enter. Done. Executed. In case if it's showing error, just let me know. here, something has populated, or here it was. Can you see?
Yeah.
See on the right side, you will have variables populated. It means our ecosystem has now these variables. So this pane is actually associated with the variables that have been populated in the R ecosystem. Okay, so see prices. See if you click here prices, can you see here prices? On the right, can you see a box, white box? Just click here and you will have something populated here, like an Excel file. Are you able to do that? I'll do it again. Just follow up. Just click it here. Click the box. If you'll click the prices here, it will show you the information only. But if you want to see the whole data, you click it here. Are you able to see this? This is now like an Excel data set. Okay. Got it? So see what's important in this data set. You have columns of two types here. One is just the column, which is SPY for Ford and Apple, and then there is time stamps, isn't it? On the left side, there are time stamps. But this timestamp has not been stored in the same way like rest of them. It's on the left. There is nothing written on the top. Can you see? This is bit different. Like you have these three columns and then these timestamps are there. Okay. This has been done by R to actually recognize that this data you are going to treat it as a time series data. Okay. Else, let's say if I do not have this times stamp here, rather than I had a date here and then these three data, then it won't be a time series data. Okay. So there is a reason. It's related to what you have to draw an analogy that no matter what programming language or interface you are working, there is a way that the software or the programming language recognizes or differentiate between different data types. So let's say if you are working in Excel, okay, Excel, when you write something, let's say A or your name, Excel automatically recognizes it as a text. You will find it as right aligned, sorry, left aligned. Okay, in Excel, you can try and check. When you write some numbers, automatically it will be right aligned. You have an option called format cells to change the way Excel should take it. Either it should take it as a character or as a number. And if you want to work on a matrix data, you in Excel you just have all this data as a matrix. Okay, when you have to work. So let's say I have this Excel data. See, this is my, let's say this is my Excel data. So if I have to work on a single cell, let's say I want to add these cells, I can just write sum and like this. Okay. So, but let's say in Excel, I want to work on the whole matrix. So it's very easy that you choose the whole matrix here. And then if you want to do something, let's say you want to copy it somewhere, you can just choose the whole matrix and do it the same way. Now in programming languages, definitely you need some other data type to recognize this kind of data. So for programming language, a number will be a separate data type and a matrix should be a separate data type for differentiation, isn't it? Else how, let's say here, can you see here, this variable prices, when I have clicked this variable prices, just clicking one variable, all this data have come. Okay. So it's like in Excel, I am choosing the whole matrix. Okay. So every programming language, the basic component is the data type they have to handle different types of data. So whenever you are working in any programming environment, make sure that you understand the data types. Got it? Every programming language has a way to handle data. Way to handle data means to recognize what kind of data I'm working with. Okay? Because here I do not have an option. Here I do not have an option to choose this whole data and work somewhere. I'll have to use some variable, isn't it? I'm using the variable prices. So every programming language has a way to handle data. So they have different data types. Got it? So now second thing is, see, once I have the data, now will this was related to R, like making you familiar with the R ecosystem and the R platform. Now let's focus on once I have the data as an analyst, what's the first thing I should do? What do you think? Let's say if you are working as a financial analyst, you have the financial data, what's the first thing you should do? Yes, you can have a summary statistic and you can have data exploration. Okay, it's part of analytics. The first component is called data exploration, or you can say plotting, because plots actually reveal or give some insight. So whenever you are reading some article like some Bloomberg or on Reuters, you will find lots of charting there, and then they draw insight. Okay, that insight is we are going to first plot it, and then we'll try to derive some insight from that data. Okay, so let's go to the next code chunk where we are going to forecast. Sorry, we are going to plot one of the time series data. So I have chosen here. See, can you see here? Just follow here. Can you see here? See my cursor, SPY. So when I write prices $SPY, I am actually fetching only this column. This column. Okay. So see here, if you write here prices is the variable which is storing the data. If you want to fetch one column, you dollar. See, if you write automatically, the three columns will show up, isn't it? So I am using one library called HighCharter for visualization, and then HighCharter has a way to plot. Okay, so you have to pass on the data. Here I am passing on the data. So I have chosen to plot SPY. Okay, so I have chosen how I have written prices and $SPY. You can plot Ford also. You have to just write here prices. That you have an option to choose which one you want to plot. Okay, so let's say I have chosen SPY, and then when you run this one, okay, just run this code, the first code, eye chart. Are you able to run? You will have a very good interactive plot coming up. Got the plot? Got the plot? Okay. Okay, so once you have the plot, you can actually zoom it. You go here, see, can you go, just see my cursor? Click this, you will have, you can zoom this plot. Zoom this plot. Got the plot? And zoom it.
See, once you have the plot, can you see here? Here you have an option on the top of the plot. Can you see show in new window? If you click it, automatically a new window will pop up. So this is my plot. Okay. So as an analyst, I have to draw an insight from this. So in the field of finance, what steps you have to take to draw an insight? Okay. First of all, you have to see whether in your data there is some trend or not. First thing for the time series analysis, especially for the financial time series, first inference should be that there exists a trend or not. And if it exists, what's the time horizon you are considering? So that means, let's say here the time horizon is 2007 to 2023. Long term horizon is there. So if a trend is going to exist, if I'm trying to say it's a long term trend, okay, and long term, what kind of trend is there? Is it the uptrend? Okay, so first inference, if you are and working on a financial time series, is to see if there exists a trend or not. Okay. Second thing, which you had, which you won't find in financial data is seasonality and cycle. Okay. Which you won't find in financial data, but still I'm mentioning because let's say if you are working on economic data, then you can have cycles, business cycles with it. Okay. And if you are working on a marketing data, okay, or some product data, then you can have seasonality. So let's say seasonality, one example will be, let's say you have a sales data, time series sales data of jackets. So you'll find that sales to be higher in the month of December, January, in comparison to May. But this you won't find, this seasonality you won't find in financial data. Intuitively, if you think, do you like, can you imagine that there could be a case you can have seasonality in financial data?
Kind of maybe, in and around where kind of governments announce their unemployment numbers or kind of, you might see some movement in their currency.
Yeah.
Like, and that's, those numbers are published every, so often, that's a different type of season. But
Yes, so what he's trying to say, it is more associated with, you can say, cycle.
yeah,
So let's say if you are saying that there is, so we have monetary policy, okay, and the fiscal policy, which is most often done quarterly, reported quarterly, most of the time. So those times whenever there is a reporting, let's say GDP reporting is there or policy rate revision is there, so maybe some cyclicity can be seen in your index performance. Okay, so that that's going on at a micro level. So in that case, if you want to focus, I would suggest you to shorten your time period. Let's say 2 years or 1 year. This is a long time period. So I can have a data, let's say from 2010 to 2012, where I want to see. So you will have a short period, and then you can see that, let's say for each quarter, do I have some commonality in pattern? Then you can have a graph, let's say of policy rate, okay, for 2 years, vis-a-vis the index plot, and you can see whether some kind of association is there in policy rate and this index. This is how you have to infer it. Important thing is, it's a perspective, okay, but perspective has to be validated with something which has really happened in the past. Okay, so whenever you read a, I'll say read a story or a column from an analyst, he has woven it in such a way that you have only an option to appreciate it because he has connected the dots in a way
that something that has happened in the past has been showcased in the graph. Okay, so let's say in this graph, do you find dips? Dips, or you can say when the market is down, because this SPY is a broad index for S&P 500. So for what time periods you see a dip? And try to think whether those time periods are associated with something that has happened in terms of global macroeconomic event or global something. COVID you'll find, and 2008, 9 you'll find. And you will also find somewhat around Eurozone crisis, 2010. Yes, yes, 2010, 12 you'll find. So it's a long-term graph, that's why you cannot see that dip. If you start find a dip around sovereign debt prices, Eurozone sovereign debt prices. Okay. So, and especially if you focus on certain nations like Greece, Portugal, Italy, and all, so you'll find more dips there. Okay. But for S&P 500, one inference would be that market was hit more worse during COVID than subprime crisis. Isn't it?
Yeah. It was more.
The fall,
More sharp.
the fall is more sharp, more pronounced during the
The rise
COVID.
is still is also recovery.
Yes. Market recovered, no? But then again we are talking. Can you see the dip again? Because this is like the most again, it's a news. World Bank is talking about contraction, okay, and firing in the workforce. Maybe they are expecting a new recession to come. So market reacts in response to it. So you will again find some dips happening.
So there's a dip there. And
Yes, around
2022,
22 to 23 you will
that was
find a dip.
really- And I can't.
Supply chain problem.
Yeah.
Supply chain problem was more during COVID.
Yeah.
Was more during COVID.
I think towards the end, that was, you know, the
This was the time when, so actually European Union as well as the US, they were targeting for so there lies a trade-off between unemployment and inflation. So US government as well as European Union, they sustained a very high inflation just to combat unemployment for very long. Okay, it happened for very long. Recently, the policy rates have been revised, and whenever there is a Fed tapering, or you have the Libor rate set, once you have this Fed tapering happening, Libor rate set across the world, the economy, like emerging economies and all their central banks, they also revise their rate. So there is an interconnection. There always lies an interconnection. But what's important here, I would like to say. So see, this is S&P 500 is one financial data which can serve as a proxy to showcase that whether something is wrong in the market. But there are other proxy also. Let's say if you have a long-term bond, okay. Long-term bond inversion has been used in academia as well as by the analysts to be a better indicator to show that something is going wrong in the market. Because there will be a shift in investor sentiments from a risky asset to a less risky asset. Okay, I would say less risky. Government bonds, they also are volatile. Okay. So important is, as an analyst, it's not only that you have the plot done, the inference and insight should be more. And then what data you are using as a proxy is also important. It will depend upon your objective. Okay, so let's say I have to, I am bit skeptical about my investments in the future. Okay, and investors are also like they have heard so many news and all. So then in that case, I will prefer to use long-term government bond data and reflect upon that data to have some insight. So choice of a financial data and the inference both are important. and it's guided by your objective. Okay, is it clear? The stuff that we have done in R, it's just a tools, it's just a tool to achieve a final mean. It's not a mean in itself. Okay, so don't think that I need to be very sound in R. It's not important. It's more important that you should know to draw insight. You should know which data I have to pick up. Because today we have R, Python, tomorrow maybe some other language. So what's important? Because it's not the meaning itself. It's just a way to achieve the mean. The final mean is your objective. It will be guided by your objective, and it will be different for you as an individual investor or you as a person who is handling some portfolio or suggesting some time. Is it clear? So, but yes, the important thing, step one in time series analysis will be data exploration. Okay, so first you go for data exploration, draw some insights, jot down some points where you have some commonalities, some patterns emerging, some asymmetries. Okay, and then weave a story out of it. Clear? So let's proceed to the next stuff. So you can also have the summary statistic, which I won't focus more. Okay, though it's important, summary statistic means that you have the mean, median, mode, standard deviation, and all those things. Okay, it will take time, so let's move on to our next objective where we are going for forecasting. Okay, but since we are going for forecasting and since we are going to use a statistical model, so first thing that should come to your mind that I have to use probability. Okay, and if I have to use probability, I should try to make my data resemble some known distribution. Then only I can proceed with some statistical analysis. Okay, so step by step, because I am going to work in a statistical framework. If I am going to work in a statistical framework, I have to work on a data which resembles with some known distribution, because with known distributions, there are certain good characteristics which I can attribute to my data. Is it clear? What I'm trying to state? What I'm trying to state is that since we are going to work in a statistical framework, we should try to work on a data which resembles some known distribution. Because known distributions, let's say normal distribution, they have some certain good characteristics. And I can use those characteristics to have more insight about my data. Clear? So the first and foremost thing that people do to have an idea of distribution is to go for a histogram. So in R, to create a histogram, the function is hist, and then you give the data. So I am giving it SNP data, SPY data. When I run this code, I'll have a histogram.
Did you run that for all the variables?
Yes, yes.
In one go. So
Yes, you will have to create a loop. There comes the power of iteration. Okay, and then there are also ways in R to have multiple, you can say multiple visualizations packed in a single graph. Okay, but it's not our main task, so I am not doing.
Yeah,
But
sorry.
yes, you can do. So let's say if you want to do something in R, best thing is that you should ask the right question to Google. You'll find the answer. So there are websites. Yes, this is important. People these days they are using Chat GPT, but it's more useful if you ask the right question. Then it will give you the precise answer. Okay, so with time you will develop what to ask to Google or Chat GPT or any OpenAI platform. Stack Overflow is there, very good. R bloggers is there. Okay, so R pubs is there. So many websites are there to help you. You need not to mug up the code, because the purpose is not the code itself, the output of the code. So let's say I want to submit a report where I have to create multiple histograms together. Okay, and then
let's go one step further. I want to create multiple charts together, multiple QQ plots. So there are libraries where you have to just pass on, okay, all the data. It will create a very big report. Okay, so there one such library is called Data Explorer. So Data Explorer, you just pass on the whole variable prices. It will create, you know what? It will create a very good report. Okay, I'll show you just 1 second. So, but that's not the core concern. So see, Data Explorer is there, and then there is the function for create report. Okay, create report, and then you pass on prices. And wait, a report, big report will be created. It's creating the report. So you can use these shortcuts to actually just one mouse click and you have a very big report to share with your supervisor.
Sorry.
Yeah, but these are like once you know the core stuffs, it's like fine tuning your output. Okay. Else you'll have to write this much code to actually combine all those plots. Okay. See, this is the report created. This is the data it's saying about missing data. These are the histograms. Okay. These are the QQ plots. This is a correlation analysis. Okay. This is the PCA that he has done previously. Got it?
Yeah.
So there are so many libraries. Okay. But yes, let's go back to our histogram. Why we are creating a histogram? Purpose is that I want to draw an insight from this histogram whether my data resembles a known distribution. So first of all, let's know what histogram is, what it showcases. Okay, histogram is nothing but it's showing the relative frequency of any data point. So that means the 500 SPY 500 value, 500 or near about 500. It's a bin width. Don't We need not to focus upon it right now. But data point around 500 has relatively less frequency than data point around 100 and 200. Isn't it? It's showing the relative frequency. So higher the chart height, more the frequency of this data. Frequency means that in your SPY 500, this 100 value has been reached on almost 1000 times. Can you see? So are you getting it? What histogram says? It actually says the relative frequency. Okay, this is the relative frequency. So now, how do we associate histogram with distribution? Okay. So every distribution has a peculiar histogram structure. One such distribution, most go-to distribution, the first distribution that we go for is normal distribution. Though there are other distribution for extreme cases, but let's now focus on normal distribution. Your statistic lecture starts on normal distribution. Search on Google histogram of normal distribution and compare that histogram with this and say that whether it resembles normal distribution or not. Search on Google histogram for normal distribution. Okay. Do you think it resembles this distribution? So I am pretty sure that with the price data for SPY, I cannot proceed with normal distribution because it's not resembling. So one way out will be to choose some other distribution which resembles, which is a complex exercise. For the time being, I won't say to explore that. But in advanced modeling, we often do that we look for others. So there are tons of distribution, okay, based on your data type. Other option will be to go for the data transformation. Data transformation means rather than working on the price data, this is the price data, isn't it? Rather than working on the price data, I will first transform my price data. And then I'll check whether that transformed data is resembling normal distribution or not. If it does, then I will perform my rest of the statistical modeling on that transformed data. Make sense? So because my price data, I am interested to work with normal distribution. My price data currently is not resembling normal distribution, so I'll go for a data transformation. And then I'll check the transformed data whether it resembles normal distribution or not. Okay. So one such famous transformation in finance is called logarithmic return. Okay. You must have seen lot many times, but we often do not realize that why we are working with logarithmic return. So there is a reason we work with logarithmic return. Okay. Or you can say simple return also. So logarithmic return is, do we have a marker here? I can write on this folder. Let's say I have this price data. Okay. Let's say today, what's the date? Second, let's say the price is 32. This is first, it's let's say 30. So logarithmic return is nothing but log of today minus log of tomorrow. So if you know the property of log, I can safely write it as ln 32 by 31. Isn't it? So in terms of words, I can write ln pt minus 1. Isn't it? PT is price today, PT minus 1 is price yesterday. So this is logarithmic return. This is one such transformation. But it's being recorded. I will share it. Thank you so much. Okay. This is one such transformation. Another transformation is, differencing the series. Differencing the series means I will subtract like this, PT minus 1. Then second day it will be PT plus 1 minus PT. This way. I'll just rub it. 1 second. It was permanent marker. Okay. It's like subsequently you are subtracting today's price with yesterday price from today price. Then the next will be tomorrow's price minus today's price. The next one will be day after tomorrow's price minus tomorrow's price. No. You can do, but then more and more transformation. Then inside you have to protection again. You have, because at the end of the day you have to bring difference about the price itself. So more complex transformation, it works well if you are just focused on some empirical model. But as an analyst, I would suggest to go for those complex ones. In academia, for publication and all, we go for it because we have to actually strictly adhere to some statistical. Okay. But here you are comfortable with, let's say, differencing or logarithmic return. So next we'll do a logarithmic return in R. So this is C. You can go here.
Can you see here? You can go directly to this heading. Time, time average inference and introduction to stationarity. On the right side, can you see? See on the right side outline. Outline, you have the outline. So there you will see time average written somewhere. Time average inference. Yes, if you click it and you scroll down, you have this log return calculated. Okay. So see, this is the function to calculate. You pass on the data and then you say the log. Method equals log. Okay. If you run this, you have the log daily return. Log daily return will populate here. See, this is the daily return for my 3 data series. Okay. Able to get it? So, done. Once you click it, then you'll have this. Just one second. With a mouse click, you can do it with one function. And then if you plot, see if I am plotting the histogram for SPY return series, see the histogram. Now if you'll see this histogram resembles with the normal distribution histogram. Okay. So that's one of the requirement. Conceptually, that's the reason we go for data transformation, because in a statistical modeling, we need to have a data in a format with which we can associate some, you can say, distribution. Okay. Shall I proceed?
Okay, Sushma.
Pardon?
You had a hash performance.
Oh, it was a comment. I had commented before. I had commented before. If you put a hash before any code, it's going to be a comment. Okay. So, and now second important thing is, now we are moving towards forecasting. Okay. Forecasting what? I want to see as a customer or as an analyst to know that future, that means S&P 500 index price tomorrow can be numerous. Okay. There could be numerous possibilities. But I'm interested to know on an average what would be the value to it. Can I think in this way? Because I know
that tomorrow S&P 500 will be it can be anything. So when I, as a forecaster, if I had to say to you, I would better position my argument by saying that I think that on average S&P 500 is going to 500. And you will find people actually, whenever they forecast something or say something, it's based on that they think that on an average it should be, isn't it? You cannot say for sure that it's going to be 500, 600. That value that you are reporting is an average value that you expect, isn't it? It's like weather tomorrow. Okay, so weather tomorrow you don't know, but when you say that I think it should be 30 degrees or something. So what you do, you are actually reporting this as an average. Okay, as in you think on an average this should be the value. So mathematically, when I am going to forecast the price of S&P 500 tomorrow, it's going to be the average value, or you can say the mean value. Isn't it? This is what I'm trying to say. That my objective will be to forecast on an average what it should be. If so many values are there, okay, so there is a possibility. See, if I draw here same histogram, there is a possibility of having extreme values. Okay, these are the extreme values, and this is going to be your average value. So average value by default is you expect the frequency to be high, isn't it? Because extreme values are like a rare occurrence. It's not going to happen day to day. Okay, there. So if you are clever enough to actually have a insight that tomorrow the market will be down by 20%, so it's not easily like you cannot think of such a sudden spike. Okay, but I can have an estimate of an average value tomorrow. Okay, so this is what I am concerned about when I am forecasting my mean value. Now, why I am trying to say this? Because when I am trying to forecast an average value, so I would like to, let's say I know regression, and I am going to use a linear model or a regression model to forecast my future price. So in regression, my objective is actually to fit a line in my data set such that the real observation and my predicted line has least error, isn't it? This is what I intend to do. So I want to fit a line, a mean line, you can say, in such a way that the error in that mean line and the observed value is least. This is the whole concept of OLS, ordinary least square estimation. So see why again the transformation is going to work for us. This is plot for SPY. This is plot for S&P 500, isn't it? Now, can you imagine to fit a line here, a mean line, for which you can have least error? Let's say if I have a line like this, then for sure for these values, error is going to be very high. If I also have a line like this, then also I have extreme errors. Okay, so it's very tough for me actually to fit a straight line such that all these points are very much close to that line. Are you getting what I'm trying to say? We are trying to fit a straight line, no matter it's like this or like this or in any way, that straight line should actually pass with all these points as close enough. Yes, I am trying to actually put a line such that these points are very close to that straight line. But in this case, it's not possible, isn't it? Because see, we have, if you put a line like this, you have so much variation. But see the plot for the return. Can you see this return plot? If you want to say that can we have a mean position here? Can we have a mean position here? I can have a straight line like this, isn't it? Where, so there are fluctuations across this straight line. These fluctuations are nothing in financial jargon we say as volatility. Okay. So we'll come to the volatility modeling, but here we are focusing on the mean line, this line. Okay. So this is what we want to forecast. Now, bit technical, what we are going to do is to use one workhorse model for financial data, for financial time series forecasting, which is called ARIMA. Okay, so go to this ARIMA. So ARIMA, you have to decompose this ARIMA into three components. Can you see? AR is auto regression, MA is going to be moving average, I is integrated. This integrated is nothing. This integrated is actually trying to bring that straight line concept. Okay. So that means this integrated is going to bring transformation in your data such that you can have a mean line. In financial jargon, we use the term stationarity. Okay. So many people are like, whenever you are doing a financial time series modeling, the first thing people do is to make the data stationary. But there is a statistical reason for it. Okay, this is the reason. So this ARIMA having this I embedded is actually working on that stationarity aspect, where we are trying to put a mean line. So that volatility across the mean is low. So mathematically, I want to state that I want my data to have a constant mean and variance. Okay, that's what I intend to. So this I is going to work on that side. Auto regression is related to the past data having the information to forecast the future. That means, let's say time series today is something. So I assume that the past 3 days data has the information to actually forecast the price today. Now, important thing is, for how many days I have to take the past data, that's again called tuning. You will have to tune that value, that till how long in the past I have to take. It would be 2 days, 3 days, 4 days. So in R, you don't have to bother about it. Statistically, there was a way, but in R, based on one, there is one method based on entropy. You need not to focus on what that method is, but automatically we have a package which is going to tune your parameter to show till how far in the past you have to take the information. Okay. And the last one, moving average, is actually balancing the error that can creep by having the auto regression. So it's actually working on the error term. It's like, let's say, based on your model, your forecasted value is more than what is really observed. So this moving average will actually reduce it by having a negative coefficient. If it's less, the error, so if your value forecasted is less than the observed, so moving average is going to do what? It will have a positive coefficient to balance it out. So auto regression and moving average, they are actually work so well, they are so balanced that what I have seen for financial time series data, this ARIMA model has many times outperformed Bayesian and machine learning methods. So you can check in academia, number of papers in academia. I'm talking about financial time series, not any time series. If you check, you will find this ARIMA model has literally outperformed very advanced models. So you have so many, you have deep AR, okay, you have Gluon TS, then you have one Google model is there. What's that? It's famous. So one Prophet is there. Facebook also has an algorithm called Prophet or time series forecasting. Okay. and Deep AR is there. One is from Google. So these companies, they also have their time series forecasting algorithms, very advanced algorithms. Still, for financial time series, this ARIMA model stays as confident and as reliable that it used to be long time. So it's a workhorse model for financial time series forecast. Okay, that's why it's even taught today with so much interest around. So any financial time series modeling starts with this ARIMA. So how to implement this ARIMA in R? Very simple. There is a package called forecast. Let's try to run it and understand it. So see this package is there, library forecast. Okay. And see here, you need not to bother about data transformation, how many previous terms you have to take, nothing. You just have to call this auto.arima and run it. Okay. So I have this output stored in fit_spy. Okay. So now, if you remember, you had so many outputs. So see, there is a way to see the output. R is an object. So if you write view and if you write the output fit_spy, you can have all this stuff here. So many stuff are there. The output has been clubbed together and stored as a list here. Okay. And based on your interest, you can use it. But if you want to have a summary of this, you can just run this output and you can have a summary. This is a brief summary. Now just focus on this brief summary. Can you see these two terms? Automatically, this model has tuned the three parameters. The three parameters, the first parameter is associated with the auto regression term. Second parameter is associated with the integrated or stationarity term, and the third is related to moving average. So 2 here means you have to use past 2 data. Okay. Here we have a daily data, so that means past 2 days data. This 1 means here that you have to difference your series once. Okay. Difference your series once means this one. If it would be 2, that means you have to difference your series twice. And then 2 here, last one, means you have to use past 2 error terms. Okay. So see here, the coefficient are AR1, AR2 coefficients are this. Okay. MA1, MA2 coefficients are this, and this is a drift. So if I have to write the equation, what should be the equation? This is the equation. Coefficient of first term, is it visible? Okay. This is previous day data. Okay. Here Y is actually not the, if X is the original data, then Y is actually, you can say X2 minus X1. Okay, because it's a difference data. So in statistic, we write it like this, delta X. You can write delta X also. So this is a difference data. This is not the original time series. Okay, it's a difference series. Then you have YT minus 2. Then you have MA1 1.78, and then your MA2, and this is the drift. This is your whole equation. If you want to forecast, so again, forecasting using the package is very easy. Okay, you just have to pass on the time horizon. So this is the time horizon. Let's say I want to forecast for next 10 days. This forecast horizon is also an art, because let's say your data is only for past 20 days, so you shouldn't try to forecast for next 10 days. It's not advisable. You should have enough data. Okay, so you more the forecast horizon, more the chances of inaccuracy for longer time horizons. Okay, so but yes, you can use this function forecast. You pass on. So this is actually a pipe operator in R. I am passing on the output of ARIMA model to this function forecast, and I am stating that forecast for 10 time periods, and this is plotting it. Okay. So
This is your, see, that's what I was trying to say. Can you see this is a straight line, kind of a mean line? Because we, with ARIMA, we are actually forecasting the average value or the mean value. Statistically, we say that we are forecasting the conditional mean. Conditional mean because this mean has been forecasted based on the information set, which is the past data, conditioned on the past data. So it's a conditional forecast. What type of conditional mean forecast? With the information set of what? Past data. All those things that I'm saying has been written in this notebook statistically and intuitively also. You can go through it. Okay.
Really, it deals with time series where you have to move away from like a day but more like a time period. Like for this, you can see your time output is kind of like your Excel format of day, you know, where it's numbers.
Yes, because this auto plot actually has it, but you can actually have this data and plot it with the time plot.
Say if like we're trying to generate an equation like a line this for ARIMA. Do you ever find yourself where you're saying, okay, well, the days more days, days, maybe I should look at instead of a day and another day, maybe on the days between days. Do you ever find yourself having to?
So I what you are saying because what happens there are gaps between days because the market is slow.
But like maybe it's for say weekends or.
Yes, yes. So in that case, actually, what happens because this statistical model is actually assuming every day aligned at a common. So it's not. Yes. What you are trying to say is right. That because market is closed on weekends.
Yeah.
Okay. So after Friday, the next time stamp is not the next day. Yeah. It's on Monday. But I assume that whenever the market is open, all the forces that can shape the price are working together on that day and they are shaping that price. So on weekends, these forces are not shaping any price. I am assuming that whatever price I will be observing, it's on Monday. And in morning, mathematically, it's going to treat it as a next day. Yeah. At a like same time stamp. Okay, though technically it's not. On weekends, there is a gap of 2 days. But that's a good question. That because time series data here it's not equally separated. Because on Friday when the market closes, the next time stamp is on Monday. There is a gap of 2 days. So that's why he is saying that you have encountered this problem that this forecast is not for the next day because you have maybe 2 days. But mathematically, it's going to treat it as like every time stamp fully separate. Okay, that's a constraint.
Did you ever see you changing dates into big days? So would you say that you're more confident with the ARIMA output based on just days, or it's just looking at dates, or should you interpret those dates as differences?
So you should interpret it based on your, uh, let's say the forecast involves a weekend week. So in that case, you should put it that it should be next day. Like the next trading day,
Right.
not the weekend. But yes, important thing is that ARIMA output is not important standalone.
Yeah.
We also have that volatility. Which will come. You cannot, you shouldn't only rely on that mean. Why it's important? Because as a analyst, apart from the average value, we are also interested in the uncertainty, where the volatility model comes in. Okay, because see this is actually showing the area about what all other values can this value take. Okay, this is the average value, but these are the all possible values. So, but it's not reported here because I am just forecasting the mean. As an analyst, apart from the average value, I am also interested in the uncertainty, or you can see the dispersion across the range.
Yeah.
Okay, so you can say volatility. In a crude way, I am interested in volatility too. Okay,
Let's say your equation is 1.76. You think this will change instead of me saying 7th of July, 8th of July, 9th of July, I said 0, 1, 2, 3. So instead of the day, it's more the difference. Is there any issue like that?
mathematically, is written only on day.
Yeah, okay.
But when you report it in terms of date, that's right.
Yes.
Let's say if your report involves where a date is falling on weekend, so rather than if let's say it's a forecast, after that you should say that it's the next Monday.
Yeah.
Okay, it shouldn't dates because there will be no price observed.
Yes, yeah.
We observe the price, isn't it?
Yeah.
So price will be observed the day when the market is going. So Monday, if the price is observed, if that forecast period is, let's say, falling on a day which is on weekend, so we take that next trading day.
And interesting, quickly in comparison to something like the Monte Carlo simulation, for looking at ARIMA.
It's a good question. Monte Carlo simulation is again one approach. So you have to, that's a good thing that you have got. So there are different approaches. Actually, one approach. So if I try to segregate it, you can see that statistically we have two approaches. One is based on frequentist approach. One is based on Bayesian approach. Then one approach is based on machine learning, and one approach is based on simulation. That simulation approach is where we will try to actually create number of scenarios, and then based on a number of scenarios, we will expect an average value. We will fit a distribution, which in general will be problem because we have so many data. A central limit here will come, so we will have a normal distribution, and then we can do that. That's again, so all these things are, it's not universal truth. It's based on approach. This approach is aiding me as a decision maker to have an informed decision. But this decision is right or wrong, only time can tell. Okay? You are not sure.
Yeah.
This is just an approach that we are exploring. But yes, it's good that you brought it, that we should see everything whenever we are working in empirical modeling, we should see everything just as an approach. We shouldn't marry with it that yeah, this is universal. This is the only way. It's not the even in statistical modeling, you have different ways. So ARIMA also has got many variants. And then you have Bayesian estimations where your coefficient, here the coefficients are fixed, single value. There the coefficient itself is a distribution. Got it? So those are all approaches based on your objective, but I would prefer as an analyst to stay as simple because at the end of the day, my another objective is to convince my colleague or supervisor. More easy, more simple to understand, better will be like my assessment, okay, of the records, but it's very important. Technically, if you go for empirical modeling, there is no limit. This whole quant finance is like a vast ocean. Like you cannot cover everything. There are so many approaches to solve a problem. You can have some approaches come there, they have been borrowed from chemistry. Some approaches have been borrowed from physics, quantum mechanics. Now we have quantum computing also coming up. So you have quantum computing based forecasting method. Okay. So whenever people are so what in reality what we do, let's say if you have this task of forecasting, you should have a suite of algorithms. Okay. Let's say 30, 40 algorithms you have, and then you just pass on the data and you have a KPI. Okay, so there are KPIs also. Let's say one KPI is minimum absolute percentage error. Okay. Based on your forecast, you have to compare for all those algorithms, what's the minimum absolute percentage error? And then it's not a generalization, because today maybe this algorithm is winning, tomorrow maybe some other algorithm. Okay. But the objective will decide what approach you take. So let's mind only sole objective is to have a forecasted value and choose which is the best algorithm, which may be limited for a quant trader. But as an analyst, you have a broader role. There, these forecasts are actually serving as a signal. Okay, signal of somewhat, let's say once I have this value, the mean value and the volatility value, it should serve me as a signal that I'm expecting this to be up or not, and to what extent. Is it going to be risky or less risky? Okay. So you have to bring that intuitive picture. So again, it depends upon your end objective. If you want to work as a quant trader, so then it's solely the forecasted value, and then the comparison of algorithms will be important. But if you are working as an analyst, you have to take the informed decision. So then this value is actually going to help you serve for client suggestions and all. That whether they have this, we go for this or not. S&P, I expect that it's going to be up or not. Got it? So can I proceed? So yeah, so we have covered this ARIMA algorithm. No, actually, T value has not been reported here. You have to, you have to calculate the T test statistic, and then based on T test statistic, you have to calculate the P value, and then compare with your alpha. Okay. So then you will, and then based on your degrees of freedom, you will use the T value chart to get the P value and then do all those stuff. But here the best part is that this uh, package forecast. So you can rely on this package. All these values are statistically significant. This is it's based on, so there are again tuning of parameters again has different approaches. One approach will be, a crude approach will be that I want to minimize my forecast error. One approach which is gaining popularity is based on entropy. Entropy is related to loss of information. So this is the most recent approach. So this tuning of parameter is based on entropy. See AIC, can you see AIC? AIC, BIC, can you see? Lower the value of AIC, BIC, better the tuned parameter. Okay. So this algorithm actually tries to find out a value for your AR component, I component, and MA component that minimizes the AIC. Okay. And based on those reported values, you have this tuned parameters. Okay. This is a fairly new approach. If you use some old softwares, they have the old algorithm. But these days, if you run Stata or eViews, you have an option to choose AIC, BIC. You can see it there because it's based on entropy. Okay, for the time being, just see in this way that whatever algorithm I have to choose, I should have a KPI. Okay, so one approach of KPI is based on entropy, or you can say information loss. And it's reported, or you can say empirically calculated using AIC score or BIC score. Okay, lower the AIC, BIC score, better are those parameters. Got it? Yes. Auto ARIMA. See, it's written auto ARIMA. Yes. It has been taken care. So like implementing this in R is fairly simple, but technically, if you want to think, let's say if you have to do on your own, you have to tune these parameters. These three parameters, you can see
2, 1, 2, you have to tune it manually. So one such approach is, earlier people used to use a chart called correlogram, which is this one. Many of the books you will find this charts. Okay. This was a manual method done long time ago. So there it becomes less of a science, more of an art. As a forecaster, first you'll generate this chart, and then what you'll do, you'll set the P. Now, in current day scenario, what happens that as an analyst, you are working on 1,000 time series. Okay, so you will create 1,000 charts, and then you will analyze 1,000 times. So then better way will be that I have this auto.arima function. Why? What I'll do, I'll create a loop. Okay, iteration. So one by one, I'll take one column, I will forecast, I'll store it. So this way, I am not constrained in terms of my number of time series I have to forecast. But then again, uh, once it swells up, you will have to go for, you can say, distributed computing or parallel computing. So current modern day finance is struggling more to work on a big data. Okay, we already in finance have so many complicated algorithms, but when you go on implementation, because realistically in firms, they are not working on one data set. In academia, we have one data set. It's very easy, no matter how much complicated algorithm you have to compute it on just one data set. But if you want to practically implement it, even basic models, they struggle. Because let's say in reality, S&P 500, if you see a NASDAQ or NYSE, so S&P 500 are just the blue chip companies. Many people are interested into penny stocks. Okay, so they are going to have small cap, mid cap, all those three Russell 3000. Okay, so then you have that big data issue. So then it's a another problem, which is like uh, where you have this parallel computing. So parallel computing also you can do in R based on your course. You can split your task. Let's say I have 4 cores. So for 1,000 data series, I can have 4 hour sessions running, 250, 250 in each. So parallel computation will be there. I can have, I have split my task. So my final time of execution, and like I have speeded the time of execution. Another way is that today we have uh, cloud computing and everything available. Okay, so you can have subscription of Azure or AWS. These days, the people, most of the firms, they have subscription. So there is no limit of splitting the task. Okay, pay as per your usage. So there is no limit on RAM. There is no limit on processing power. Whatever you want to use, you just have to pay. So most of the big financial companies, fintech firms, they have taken subscription of AWS or Azure. Okay. So rather than having an in-house implementation, they run on the cloud. Okay. So you don't have to procure a very heavy supercomputer. You can do it. So this is like how the tech world is transforming the field of finance. Okay, so current day finance professionals, they have to be taught not only in terms of technically understanding these things, but also how to implement it on a large scale. That's how the program has to be transformed. Okay, then only it's going to be of some utility to you. You won't be working on a single time series. Okay, so but yes, this we have a 3 hours lecture, so we'll have to limit ourselves to the basic stuff. So next one is, this we have talked about forecast. Mean value. Now, as an investor, apart from the mean value, I am also interested about the volatility, how much uncertain you are. That means I have to report that I expect my data to have an average value, let's say 500, but I also expect a volatility of this much percent. Okay. So that means I also have to forecast volatility. So to forecast volatility, again, the same concept going to come. Okay.
I have to rely on my own information, that means my own volatility data. And then based on own volatility data, I will be forecasting the future. Got it? Same concept. I am going to, first of all, I am going to the regression model. So for regression model, first I have to establish that my volatility data is bearing some correlation with the past data. The volatility of the past value are bearing some relation. That means they have some pattern coming out. They have the ability to predict future. So in that case, I will be so first person to observe that was Robert Allen. Because he gave a model called R. Okay. Why it's important? Because first of all, he was the first person to notice that stuff. That volatility has some pattern in it. So we'll see that now. What's that pattern? It's the typical characteristic of a financial time series. So this is what he observed. Go to volatility models. Okay. So motivation and everything is written. So he actually tried to work around with, so there are different types of volatility, okay, just not one volatility. So he actually tried to plot some of the volatilities, and what he saw, see, this is a absolute log return and this is a, you can say, square return. Okay, so what he saw, see what's important, if you see this plot, what's important in this plot, that if you have a time period of high volatility, all of a sudden you don't have low volatility, it persists for a time. If you have a low volatility, it persists for a time. Again, if you have a high volatility, it persists for a time. That means if market all of a sudden there is a high volatility, it persists for a time. It's not going to die down all of a sudden. So this volatility persistence, this observation actually motivated Engel to come up with a volatility model. Okay, because let's say all of a sudden after this observation, if the volatility dies down, that means this high volatility is not going to predict the future volatility. They bear no correlation. They are like completely random events, isn't it? Because let's say today if the volatility is, let's say, 10 units, tomorrow if it's 0, again tomorrow it's 20. So then it, what it shows, that these volatilities that are being observed are random, but this is not the case. If it's very high, it remains high for long before, see here, it's long period we are having high volatility before it reduces, and once it reduces it stays low. Okay, so this observation actually motivated Robert Engel to actually come up with volatility model. And then he came up two models. One is called the ARC, and the GARC is a generalized version of ARC model. Okay, here the difference will be in ARIMA, your return was the dependent variable, or you can say the price series finally. But here your volatility, or you can say your sigma, is going to be dependent variable. Okay, so finally, if you want to see or understand volatility model, has got two components. Why it has got two components? Because see, volatility is associated, if you see this graph, volatility is actually associated with this. Okay, so if I have to work on my time series, first I have to take out the mean value, and then I have to work on the volatility. So core of any volatility model is going to be a mean model, which we have done here as ARIMA. So first you will run an ARIMA model. After running the ARIMA model, you will be left with the residual. Then on that residual, you will have a volatility model. Is it clear? So earlier people used to do it on their own, so it used to be very complex exercise. But in R, you have packaging. You just have to pass on the value and okay, so let's try to see how R actually implements that volatility model. Is it clear? You have any doubt, any questions why we are doing this? So see here, this auto correlation test and everything is there to test for existence of correlation. Okay, so I have written here, you can go through it, but let's move on to this volatility model. So see here, this is the residual series. I have made this to help you understand that the core of any volatility model is first implementing an ARIMA model, then extracting the volatility, and then working on this volatility model to again. So what people used to do, because they used to do it manually, first they used to run a ARIMA model. Okay. After fitting the ARIMA model, they had the residuals. Then on that residual, again, they used to run the linear model to have the coefficient. But we can in R do everything at one shot. So you can go here. Can you see fitting GARCH model? This point, last one. Okay. Fitting arc model, GARCH model. So see this function, there is a library called RuGARCH. It's a big library in R. If you have not installed, so install it. So how to install a library? See, the way to install a library is just type with me, write install. You will see install.packages. Can you see? You click here, you write the package name. So it's RUGARCH. Okay. And then make sure, though people don't say, but I say, because some of the packages have dependency on other packages. So write dependencies equals to, right? And then enter. So this UGART will be installed. Try to install this UGART package. Once you close your R session, and if you reopen it, make sure you import the data again, because it's not going to load the data for you. Close the session. Okay. So let's finish this off because we have 30 minutes now. So see, once you have this done, you import this RuGARCH package, and then you have two functions to work around. See, this is one function, UGARCH spec. Okay, two core functions are there, UGARCH spec and UGARCH fit. This is what you have to, if you want to explore that what it is, you can ask for help. Okay, so I'll not write here what has to be done. Question mark UGARCH spec. So you have to pass on that for volatility, what model you want. So there are different variants of GARCH. Okay, we are using the basic variant is structural GARCH model. Okay, so short form in R is SGARCH. There are so many GARCH models, GJR GARCH, so many GARCH. So you can also have see. So you have to specify R that which GARCH you want to use. So the basic GARCH model is structural GARCH.
and then it will ask for the order. Same way ARIMA has PDQ, it also has the order, that what order you want to fit. I have personally seen none of the last option order than one. Sometimes you can have two, but mostly you will have good results with order one. Okay, that's my personal observation, and you won't find like going to higher orders. Okay, so but again, this is also of parameter tuning. You will have to tune it. It's a complex exercise here because R doesn't comes up with a automatic parameter tuning, which was there in ARIMA. And then ARIMA order here will be, you have to, based on your past ARIMA exercise, you can choose any order. I have given anything, but you have to tune based on your auto ARIMA. Okay, so and then you have to see, I have given here the ARIMA order. This is the mean model. This is the specification for the mean. Okay, this is the specification for volatility. Okay, and then you have to give the distribution that you want to use. So there is, don't go into the complexity, but for the time being, go with the normal distribution. You have an option to choose which distribution. It depends upon your volatility distribution resemblance. Okay, and this is omega here is related to your intercept. So once you specify the GARCH model, so I have specified the GARCH model. Now I have to run the GARCH model. So this UGARCH fit is the function. It will require you to first of all pass on the specification. So specification has been stored in this variable, and then data is square of log return. You enter, and then you will have a UGARCH model. It will take some time because parameter estimation in GARCH model is a bit complicated. Okay.
And your square log returns, your auto arena on that is just choose.
So it all depends on you. But in programming language, you have this. With software, you have split. And then here you can use the output of one model as an input for other. So volatility models output are actually used for that.
Yeah, I think because here you're saying auto arena the square of log return. Thank you.
And you can check on other volatility. So some people actually volatility is an indicator of intuitively volatility is an indicator of uncertainty. Now the question is that what what's the estimate of volatility? How are you estimating volatility? Which volatility I assume is a right indicator of uncertainty? Okay. Because standard deviation is just one approach to measure. Okay. There are various measures of volatility. One such popular measure of volatility is based on R. So this volatility again serves as an analyst give an insight about some stock performance, that how much volatile it is. So you can plot actually rolling standard deviation. Rolling standard deviation means that standard deviation, how do you calculate? You take the data and you calculate the standard deviation. But rather than calculating on the whole window, you take a window size, let's say 30, and you calculate standard deviation and then you roll over the window. So you have a rolling standard deviation. And if you compare the rolling standard deviation with GARCH volatility, you will find a difference. Okay. So standard deviation, one of the crude measure of volatility, with which we start our statistic lecture, that this is the way to measure the deviation or dispersion. But in today's world, we have different measures of it. One such measure of volatility is GARCH. Okay. So GARCH volatility, and then as an investor or as an analyst, you have to draw an inference from that volatility. In terms of that, you find the stock uncertain. How much uncertain? Because at the end of the day, your investment is going to be guided by your risk appetite. Okay, your risk appetite, and if you are suggesting this to a client, is okay. Let's say if a client is having a low risk appetite, so you know that I have stocks which are having less volatility. Now the next question will be, which measure of volatility to rely upon? Should I go with standard deviation? Because maybe one of my colleagues told me that last time I had taken standard deviation, and when I chose the stocks, I found the price to be, it became a high risk game for. So maybe in that case, standard deviation should not be the right measure of it. So the use case of this dark volatility is as a substitute for the crude measure standard deviation value. Okay. So because see, different people will have different objectives. A quant trader is going to use this dark volatility in his trade position. Okay, so he will create a mix of portfolio where he will use the measure of risk as dark volatility. So they also have to create a portfolio. In portfolio, you have one return, one risk. So risk also has to be empirically estimated. So he will change the variance with this value. Okay, but for an analyst, this volatility is going to serve as an insight whether to choose based on the risk capital. Okay, so once you have run the GARCH model, finally tuned, you have to first tune the GARCH model. Once you have to tune the GARCH model, you can have a volatility plot. Okay, so this is the volatility plot. This is your volatility, GARCH volatility plot. Okay, so see, this is the GARCH volatility plot. Now from this measure, you can see that for some time frame, the volatility is high. Okay, now what? An interesting thing that has to be observed and cross compared with what we started today. See, it's very important. Just pay attention here. If you remember, we started our lecture with the data exploration of price series for S&P 500. We saw a very high dip during COVID-20 to be more than subprime crisis, isn't it? And then we deduced that the market was more volatile during COVID-19-20 than subprime. But see here, this is GARCH volatility. What picture it is? Is it different or the same? What it says? During subprime crisis than COVID-19-20. Because price spike up or down is a different thing, and volatility in the market is a different thing. Once, let's say, I know for sure that market is going to be down, then it can stay low for long. People are not going to invest at that time. They will switch to risk-free assets. Okay, so price series movement is not going to give you the right indication about the volatility in the market. Are you getting it? The point that I am trying to make. So, but our deduction, that's why I say that have a deduction at that time, because we are going to come back again what we have deduced earlier. So we thought our inference, if you have an inference from the price series that the market is more down and the market is not good to invest during COVID-19-20 because it has very high volatility or something or somewhat like that. So maybe your inference is biased. Here, what you can see here, the volatility is more. Now, again, an important thing will be, as an investor, if you see a high volatility, what would you suggest? To go for investment in risky assets or not? If yes, what kind of assets do you think you should go for? And is there a common rule that applies to everyone or it varies based on a person? Is it clear, the question? Yes, it will depend. Maybe, so there is one movie called Margin Call. Have you watched that movie? There is one movie, a Big Shot. I think in Big Shot there is a medical actually who's- he bets against most of the in Big Shot or Margin Call.
Oh, I know what it's saying.
I think it's in Big Shot. It's in Big Shot. He actually bets against the subprime mortgage. Most of the banks, they were going like they were all along they were like Merrill Lynch, Lehman Brothers, everyone was going for subprime mortgages. So they were assuming that it's going to give them a but one guy who was a medical professional, he took a short position. Heavily. Yeah, I don't remember the and IRS actually raided his house also. Afterwards. So he took a short position. So it all depends upon how you see the market, what you perceive from the market. There is no hard and fast rule. All depends upon your interpretation and the stand that. But yes, these charts, these models are helpful to at least give you an informed decision. Is it clear? For all these codes, everything is shared. You can go through this. A detailed explanation conceptually and intuitively has been written there. And if you have any other doubt, you can reach out to me. My email, I'll just write it here. Okay. So, but yes, you should know the step for the process. So you have the data, you plot it, draw an insight. Don't have a lot many deductions from it because maybe that deduction not with some other charts or the information coming up. Then you have the forecast, have a deductions from the forecast, volatility forecast, then combining all these things, try to develop a report or you can say a column, which makes you an analysis. So if in your chart you have these many outputs and inference in an intuitive manner, it will make your inference. But this is just the start. You have so many. So traders, they have other political banks and all those things. Financial analysts have already prepared charts. It from Bloomberg has a very good charting. And then you have macroeconomic analysis. Okay, that segment you can do as well. If you have Bloomberg, you have so many macroeconomic tools based on the area you are handling. So some people, let's say you are sitting here, maybe you are handling the US bond market. With the market as a different story altogether. But what combines them together is when we talk about the empirical modeling, they are based on the foundations of that. They are all taken. So if you start thinking from a statistical perspective, you think because then every time you think from a distribution perspective. This is one distribution that we have explored. So in extreme events, you have generalized Pareto distribution, Cauchy distribution, some other distributions you can use. Okay. So we'll close the lecture for today. I hope it was fine. And insightful. Reach out to me in case if you need some more help, some suggestions. If I would be able to provide any help, I'll be happy to. Okay? So, thank you very much. Thank you.